Okay, due to the fact that I am broadsided a little bit by the fact that I was not able to remember, or I did not remember, that we have a department training day today. And because of that, for period 1, 2, and 3, they do not get the 2 hours of review that I had planned to have this week, which seems so very convenient and well placed. So I'm making this video instead. You need to look at the whiteboard. I'm moving on. I'm not going to describe anything except giving you the announcements. Make sure you look at these announcements carefully, except for this box right here, because for you, this isn't going to happen this way. But at the end of the period, I still want you to put your practice quizzes. Notice I said quizzes. There's 2 at each table. Put them back into the book so that you can, so that they will be available for periods 2, 3, as well as for your period where I'm doing this video. All right. These are recommended things to put on your help sheet. So these are things that would be very, very good to put on your help sheet. And these are problems that we went through with period 5 and 6 yesterday, and I'm going to go through those with you today so that you can see them. So I've essentially cleaned them up a little bit and put them into a text form, and I'll take it a little bit at a time and try to describe as best I can to give you an understanding of these. So would you all please look, and if you're at home, look on your practice quiz that you can see online and check right along with me, and you will find that this will be a very, very valuable video for you. Okay, in number 3, here is what we have for given and find. Read that problem and see if you can get this out of that problem so you can tell where I'm pulling this stuff from. When a problem talks about partial pressure, who is it going to be? Got to be Dalton, okay? So with Dalton's law, I like to write it just P1, P2, dot, 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 because it can be anywhere from 2 to 100 gases that you could be taking care of in a problem. But this is Dalton's law. Because it's Dalton's law, you want to set it up like this. Okay, you have the given and find up here, so you know where those numbers are coming from. Okay, the P sub T refers to the pressure, total pressure, and they gave you the total pressure, which is the left side of the Dalton's law. And then they gave you the pressure of all the other gases, however many there are, at 22.4 kPa's. And you're supposed to find N2, the pressure of nitrogen gas. Okay, so it's really a simple plug and play. Okay, as I take and plug this all in, you can see I've got my kPa's over here. All I did was put in the P subtotal, and the N2 is my unknown. When I subtract the 22.4 from both sides, you'll see that that is how I'm going to get my final answer. And that's all there is to this problem. Number 8, again, I cleaned it up a little so you could see it a little better and understand better, and we'll take it a piece at a time so it's a little easier to follow. When you're at home, it will be simple to stop the video and let yourself do some thinking, but right now I just want to tell you where everything comes from. This guy is going to be what kind of law? Don't recognize it? Boyle. Yeah, the first and most basic. Yeah, as soon as you see it. Okay, anyway, with Boyle's law, P1 V1 equal P2 V2. And so what I've done is I've filled everything in here. P1 was here, P2 here, or V2. P1 V1, sorry. P1 V1. Is that right? Yeah. And then you got P2 and V2, V2 being your unknown. And now it's a matter of dividing both sides by 150 to solve for the unknown. And your answer would be here. Charles, Boyle, Gay-Lussac, and Avogadro can all be derived from my combined gas law. So P1 V1 over N1 T1 equals P2 V2 over N2 T2. Okay? So the reason I'm doing it this way is I want you to see how easy it is to derive the laws. If you're looking for Boyle, you're going to close over these guys. If these guys are closed over, what that means is that they do not change. So if they don't change, get rid of them, and there you have Boyle's law. Okay, if you want Charles' law, that means that the certain variables are going to have to go away. Charles' law is volume and temperature, right? So we get rid of pressure and we get rid of moles, and we get rid of moles and pressure on both sides, and there we have Charles' law. Want to see Gay-Lussac's? Just switch this over. Switch this over, and we got pressure and temperature. Nice, huh? If you have a problem where you have pressure and moles, then this will work. There's no name for that other than I like to call it the Avogadro principle. The book uses that term a little bit differently, so I'm a little dangerous with that, but basically this is because of Avogadro. The next thing you absolutely should have on your help sheet is what STP is all about. What does that thing give you? First of all, it's standard temperature and pressure. And what is the temperature? It's 273 Kelvin or 0 centigrade, and the pressure is the STP pressure of 1 atmosphere. And the third piece of information that you get from this guy is right here. At STP, only at STP, 22.4 liters is equal to 1 mole. Very, very helpful information to solve problems. Okay, we also worked on number 11. In number 11, again, let's get a shade up so we can take it a piece at a time. We had 2.5 atmospheres. I was saddened to see that this was a problem for anyone. If this is a problem for you, you have a lot of studying to do between now and Friday. Where do you find this? On that two-sided sheet that I gave you in class a couple of weeks ago. I'm going to get the link up for this so you can print it again at home if you need it. But this little string right here, this is, okay, this pressure string is incredible. So 1 atmosphere is equal to all of these things, and all of these things are equal to each other. Now, what do you need to do a conversion from millimeters of mercury to kPAs? You need to know the number and the unit of measure. And it's very simple. If you're given millimeters of mercury, this guy is 760. If you were given 500 millimeters of mercury, and let's just do that real quickly on the board, 500 mLs, if that's the given over 1, then all we have to do is find out where, not mils, what am I doing? Here we go. This would be 500 millimeters, not milliliters, of mercury, Hg, should be a lowercase g of mercury. And the other guy we need, let's get that back, here we go, is this. So now we know that 760 millimeters of mercury, let's move this over so I have a little room. 760 millimeters of mercury would have to be on the bottom. So it could cancel the guy on the top. If you'll do it this way, you'll always get the right numbers. So we got 101.3 kPa on the top. And that then would cancel out millimeters of mercury and millimeters of mercury. And the only unit of measure that we'd have left at the end would be kPa, if we had that kind of problem. In this guy, we have atmospheres, and we're trying to go to kPa. So now we know that 1 atmosphere is equal to 101.3 kPa, which is where I'm going to get my second fraction from. Okay, right now we have 250 ATMs, and we're trying to get that into kPas. And so what we have is ATMs going away, and we have kPas, and we're good to go. Next problem that we did was number 15. Cleaning it up, it looks a little like it looks like this. And so, given and find again. I think that it's useful to do given and find even with a problem like this. Okay, nitrogen and oxygen come together to form nitrogen dioxide. What is the volume ratio of nitrogen to NO2? Yes, and it is the coefficients. Remember that mole ratios in the balanced equations are the same as volume ratios. That's only for gases. Only for gases. So these ratios are defined as the coefficients in the balanced equation. Okay? So this was pretty simple. This guy, this was probably the most complicated one that you had. And let's go through this again. We went through this before, but it needed to be revisited because at least half of both classes in period 5 and 6 couldn't do it. So, molar mass was given. That's part of the problem. Are you looking at number 18? Look at number 18. See where that comes from. How did I dig that out of there? Okay, you need to learn to read your word problems. Okay, this was given. This was also given. Okay, this is, of course, the balanced equation. But this is the real given right here. That's the number that we have to do calculations from. So, as we get started, this guy is going to be our given over 1. Next, we're going to use that wonderful little thing that we just learned about that was right back here with the STP stuff. No, not here. No, where was it? No, I'm not going to find it now. So let's go back and just complete. But this is the guy you know because it's STP. At STP, 1 mole of any gas is equal to 22.4 liters. Let's get rid of that stray there. And now that we have moles of chlorine, you'll notice that what I'm going to do in canceling my units is I'm not just canceling the unit. Please do this when you cancel. Don't just cancel units. Cancel the chlorine as well. Because if you don't know what stuff you have, the stuff here is chlorine, you are shooting in the dark and you don't have a clue as to whether or not you got it right or not. If you will simply do this. Okay? Next, where does this guy come from? This guy right here, this fraction. Oops, not here. Yeah, coefficients, right in here. Let me draw that guy again. That was one good. Okay, so we got a coefficient here, and we got a coefficient here. Okay? Coefficient for chlorine is 1 because we don't know. Because it's not written, it's assumed to be 1, and then the coefficient here for the hydrochloric acid is 2. Again, I'm going to cross out the O. There we go. Mole. Okay, so I'm going to cross out the moles, but I'm also crossing out that I'm getting rid of chlorine as the substance. And now, there's the molar mass, right? Where did I get the molar mass? That was given in the problem. All right? And now, I'm crossing out moles and hydrochloric acid, And now my only thing left as a unit of measure is grams of hydrogen chloride or hydrochloric acid, however you want to state it. And when you run the numbers, you get it that way. Okay? So here we are. Remember the three things that STP gives you. Temperature, 273 Kelvin or 0 centigrade. Pressure, atmospheres. But 1 mole of any gas is equal to 22.4 liters when conditions are at STP. But we also have this gem. Which is one of the things that I use to solve this problem right up in this area, okay? Because it was given as STP. STP should have really been up here as part of the given. It was another thing that we don't actually use per se in the calculation, but it gave us this wonderful fraction right here. Next was, oh yes, this is the problem that if you get it, you get to call me over and you got a freebie, because I haven't shown you how to do this. And this is just a sample problem. Someone wanted to see how to do a PV-NRT problem. Okay, here you go. I made this up as I went. I just said, hey, you're going to get pressure, volume, temperature, and you're not going to know moles. Or you'll get three other ones, and you won't know the fourth one. What are our four things? Our four things are right here. Okay, this guy is always going to be 0.0821. If you don't have that on your help sheet, you got a screw loose. Okay, I'd like to see you leave the room today. Those of you who are with me live as I'm recording this, I'd like to see you actually have your help sheet done before you leave. You got 2 hours here, folks. Make use of it. It's your choice. You either use this time and boost your grade, or you're going to sit around and screw around and do nothing, and your grade will show it on the test. So use this thing well. And the last problem, number 25, that I'm going to be showing, I think this is the last one. Yeah, this is the last one. And let's again use the shade to make it easier to concentrate. Here's our givens. We're given a volume of 0.5 liters. Okay, we call that our V1. We're given a temperature of 18.4 centigrade. Notice I changed that immediately to kelvins. Okay, we're also given a second temperature of 100 degrees centigrade, and that, now can you look at the problem? Where did I get my 100 degrees centigrade from? You need to figure that out. And here's a piece of information that you're going to need to know. If you don't know this, you better write it down on your help sheet. If you don't already know, water freezes at 0 centigrade and it boils at 100 centigrade. And you had to know that to solve this problem, because they didn't give you that final temperature. And your V2. Okay, so T and V, who's our guy? Charles. And there's how you do it. I didn't have time to make the subscripts of the 1s and the 2s, but you understand Charles' law. And I think you're capable of plugging and playing. And that's it. You will find this very helpful. You're a lucky person if you watched it, even luckier if you saw me make it. And I wish you all best possible test scores on Friday.